Hi there, and welcome to another episode of the AI Explore webinar series. As part of these AI Explore webinars, we focus on exploring AI from infrastructure to platforms and from LLMs to Gen AI applications. This is our second episode where we would be discussing about observability in AI. When I started working with Gen AI models and applications like ChatGPT and Claude, I thought that maybe the whole idea or the whole core of AI is GPU. So if you monitor the GPU, that's fine. But it's only later I realized that that's not the thing. There are a lot of other components which are involved when you want to observe your AI applications and AI platforms. To put it simple, if you have a car which is functioning, you cannot just focus on the engine of the car. There are a lot of other components that you have to look at it. There are doors, there are tires, there are wheels, and that exact thing comes to AI as well. So when you have AI platforms, there is a different level of complexity involved, and that is what we are going to discuss today. A couple of weeks back, me and my colleague, we did give a talk at a local meetup here in India where we spoke about observability in AI. But that was just the tip of the iceberg. So if you were one of them who attended that meetup, make sure to stay till the end of today's webinar because today we are going to deep dive into observing complex AI platforms and models. But before we begin today's episode, there is an exciting news that I want to share with all of you. We are thrilled to announce that InfraCloud is the silver sponsor at the NVIDIA AI Summit that is happening in Mumbai from October 23rd to October 25th. The NVIDIA AI Summit is the place where all the breakthrough and innovations in AI happen. And we, being a part of it, will share our expertise and experiences and obviously learn from the other industry players. So make sure to drop by our booth at the NVIDIA AI Summit in October. Further, if you are new to today's webinar, you can watch our previous webinars. We have been doing webinars on platform engineering and AI as well. So you can scan this QR code, which will take you to our YouTube playlist where you can watch the previous episode of the other webinar. And like always, I am not the only person who would be talking today. I have a couple of guests with me. One of them is the first appearance on this webinar today. So we have Aman here, and we have our regular feature Vishal as well on the webinar. So hi Aman, hi Vishal. Thank you so much for joining in.
Hey.
Great. So before we start, a quick round of introductions from all of us. I am your host, a familiar face here. I am a senior developer advocate at InfraCloud, where I help organizations adopt open source technologies and platforms. I'm also a CNCF ambassador, where I conduct a lot of meetups in my city here. And outside of work, I'm a big time foodie and a travel blogger. So when I'm not doing webinars or working, you can find me at a restaurant trying out something new. So over to Aman for him to introduce us. Where is he from? What does he do? And what is one thing that you like doing outside of work?
Sure. Thanks, Adu. Thanks for having me here. I'm principal engineer at InfraCloud, based in Pune from last 14 years now. So kind of like a Punekar. Uh, I've been doing cloud native stuff, systems designs and distributed systems from last 10 to 12 years now. But from last 1 year, focus is on mapping the same things in the AI cloud space. Pretty interesting work. Beyond work, I love to read books or probably watch movies.
And Vishal, over to you.
Thank you, Dul. Thanks for having me. Vishal, founder and CTO at InfraCloud. Mostly focused on open source technologies around cloud native infrastructure for last 80 years and implementing those at enterprises. And obviously now trying to use them for the AI cloud and AI infrastructure basically. Based in Pune since almost 24 odd years on and off, I guess. And beyond work, I like being in mountains, nature, and reading good books and watching good movies.
Interesting. So we have two Punekars and one pseudo Punekar here in today's webinar, and we will be going through discussing about observability in AI today. But before we move on, some housekeeping stuff. We would be taking questions from you. So if you have any questions or queries in between the webinar, you can put it in the comments box, whether you're joining in on LinkedIn or YouTube, and I would be taking that questions with the guests as well. So with that out of the way, I think it's good time to begin our discussion. So observability is one of the major concepts where the whole idea is to get insights into a system by checking what's happening externally by looking at the metrics, logs, and traces, which is often known as the triad or the pillar of observability. And I've been a long time advocate of observability ever since I learned about this and the tools that I used. And it always amazes me how we can predict or look at various softwares and applications by tracking various metrics and logs. So what you see here in this image over here is, we have a cluster, we have namespaces, and then you have some metrics coming into Prometheus, which is then taking it to a Grafana dashboard probably where you visualize the metrics and then you have a team that analyzes it and takes action. So that's a quick observability 101 session, observability under 30 seconds for you. But then this entire landscape, when you map it to an AI platform or an AI application, it changes completely. And that is what we would be discussing today. So observability in AI is complex. That's the only thing which I will say. But I will now hand it over to Vishal and Aman to demystify that complexity a little bit and take us through the entire webinar today.
Cool. So I think when it comes to observability in AI, I think there are two fundamental things which are different. I think the way you collect data, whether it is metrics or logs or traces or anything, is not fundamentally different if you ask me. But I think there are two fundamental aspects which are different. One is obviously introduction of new components, new layers, right? So GPUs obviously at hardware layer, LLM, and inference servers or model engines, for example, is another new component we're introducing. Model by themselves, are obviously completely different and new compared to any previous software, for last whatever number of decades, basically, right? So obviously that means there are new and different things to monitor. For example, time to first token and stuff like that. The second, and which is more fundamental change in the observability, for example, if there is observability in your normal software today, there might be modules and classes and functions, lines of code, and you can go and say, hey, this is where the exception happened, basically, right? And then you kind of trace back from there what might have gone wrong in that scenario. Now, how do you do this with model? You're sending a request, model has been trained, you're getting a response, right? How do you know and how do you kind of debug, for lack of a better word, right? That what caused a certain exception or a certain response to be not right and wrong, basically, right? And I think that is something I don't think there is right answer and 100% clear answer today as an industry. That will continue to evolve. But the first one, obviously, we kind of have a good handle in terms of what to look at these components. But the second will continue to evolve, I would say.
Absolutely. I think I completely agree to you that the process remains the same, but then the way you implement it and the things that you track obviously change. Over to you, Aman, for taking us a little more deeper into this aspect.
Sure. Yes. So I think observability in AI, the fundamental difference, like I think Vishal mentioned, there are many new components got added. Like at the hardware layer, we got a lot of accelerators, and the only point for which they are being sold is like they are performance heavy. Like they do provide a lot of good performance. So do the end users have become performance thirsty. So you have to track those things if you are really using it to those performance levels, and are you using the right optimization toolings and whatnot to get those in performance benefits. So that is what we will look at it today from certain aspect of AI observability. Okay. So broadly, if you see, there are almost three different kind of workloads or areas in AI observability. So the top one being the training workloads, where you have seen like different big models coming out every day, right? Companies are training models on bunch of GPUs and all. Now, that space needs a completely different kind of observability. Reason being, you are building a new model every other day, or you are basically fine tuning it. You need to track, was it better than the previous version or not? how capable it is, run it against multiple data sets, and identify it. So that training space completely targets on the model quality, model performance, and how the entire infrastructure that supports that training workloads, how that is being utilized. Then we have a space of developing LLM apps, which is basically most of the companies are currently doing, using the foundational models, creating some kind of versions on top of it. And basically, it might be a RAG app, an agent based app. You connect it to the different systems, your policy documents or your internal documents, and you kind of build on top of it. Again, this is more of when we say talk about observability in developing LLM app space, we focus more on troubleshooting aspects of it. So like Vishal was mentioning, like the tracing part, how do you analyze, debug, and troubleshoot? So that all things comes into picture. Like you're using multiple systems, let's say vector databases, you're using agents, which part is getting slow. So you have to trace those things. And the last piece is the inference workload, which is again a subset of developing LLM maps, because when you are talking about inference, it means you are basically deploying a model. It could be a foundational model like Llama and all these things, or it could be your own proprietary model. But you're deploying it into a certain GPU based systems, and you're using it. Now, here, what matters more is your performance efficiencies and how much reliable it is. Basically, all we need is how fast you are getting the responses. That depends, because that's a crucial layer between your entire LLM app or any other ecosystem. How fast you're getting responses, how much is it you're using the GPUs at the level that is required or not. So that will be the focus of our discussion today. So we'll talk about AI inference observability as the main topic, and there are other things on LLM apps and training workloads, but probably will not cover today in this session. So when it comes to the observability, we call it like a layered approach, and it's not like something new. Even in the other systems, we might be doing it in the same way. Many companies do it in the same way. So at the bottom, you always have an infrastructure layer. Here we call it AI infrastructure layer. Reason being, there are a lot of accelerators. On the compute side, you have GPUs. On the network side, you have fast performant networks like InfiniBand, Rocky, and whatnot. On the storage, again, there are fast processing servers for storage as well, parallel file systems and whatnot. And all these need a good amount of power consumption. They need a good cooling systems to keep it operational. Racks are there in every data centers. Now, to top this, you use an operating system and an orchestration layer, and by that you get a usable infrastructure layer where you can deploy your services, we can deploy whatnot. So if I have to top it up with the AI workloads, it would be starting with an AI model backend, which is like an engine. Now, we'll talk about in detail, like what the difference between backend and serving in further slides. But in summary, it is like a server. Backend is your server, and then you have a serving layer, which is basically a user-facing layer, where your end users actually interact with the AI workload systems. So we'll go by same this layered approach. We'll cover each layer in detail in further slides.
Sorry, I was on mute. So yeah, I think Aman gave a real good, overview in terms of the layered approach to observing your entire AI platform. And the three layers that we also discussed in our previous webinar were your infrastructure, your orchestra, which includes your orchestration layer, and then you talk about the backends, and then the serving part as well. So we will start with observing infrastructure, and we see how critical your storage and networking are, and how do we observe them.
So if we say infrastructure layer, these are primarily divided into two broad categories. One is hardware, and then there is a software layer. Now, hardware is basically what is there in your data center. So you have compute servers, you have networking, racks, and whatnot. And it is critical to monitor those as well, because that's ultimately where your everything, your all this workloads and systems are running. Then you have a software layer, which is basically starts with like your operating system. Then you top it up with any orchestration engine like Kubernetes, and on top of that, if you are doing like a GPU cloud, then probably some GPU operators, some sharing plugins, network operators, storage operators, and whatnot. Now, within these two layers, what do you need to monitor and why it is critical? So if you look at hardware layer, it is very important for us to monitor the utilization metrics. And the why it is important is because if you know that all these GPUs like H100, A100, they consume a lot of memory, like around 700 watts. So one DGX box might use like let's say 8 kilowatts of memory, and a rack only has like a 20 kilowatts. That's it. So only 2 DGS boxes will come in that. So you have to be sure like your power is being measured properly, how much power consumption is happening. There is no overconsumption, underconsumption, all those things. You need to monitor the temperature of your GPUs as well. These are costly pieces, costly accelerators. So you need to be sure that they are running under the right conditions. This could indicate that whether you have to update your cooling systems, are they working fine or not? And this completely affects your entire data center design. Same goes with the networks as well, because at the network layer also you have switches, wires, InfiniBand networks, how they are performing, is there any congestion, all those things that needs to be monitored. Now, at the software layer, since we are talking about mainly AI clouds, AI observability, so you allocate GPUs. Now, GPU allocation can be like one-to-one basis, or it could be like a shared model. You projected certain GPUs. Now we have MIG in the recent GPUs, right? So you can basically divide one GPU into 7 smaller GPUs. So how that allocation happens? How do you monitor that? Are they being used effectively or not? Or that, or was it not worth doing that kind of uh, using the MIG? You needed the whole GPU, but actually divided it, and you are not getting the benefits out of it. Then you have a network and storage performance that you need to track, because all these workloads that run, they consume good amount of networking and storage. You need to be sure of scheduling efficiencies. We use Kubernetes because it can get distributed clusters easily with it, and it has all those things baked in where it can do scheduling and all those. So, but you need to make sure that you're not basically oversubscribing a node. All the workloads are going into one single node. You're distributing it properly and all this. And lastly is your pod startup times. Basically, all these applications, it depends pulled up, or if there is any latency or delay in that. So those things will be measured on those parts.
Yes, and
I think we just
interestingly, when
experienced some
Aman was
latency.
talking about exactly when Aman was talking about latency, we experienced that in real time as he got stuck. But yeah, one thing, I found it interesting when he spoke about measuring the temperature for your GPUs, because they tend to get real hot. Engineers at InfraCloud at our office in Pune, where we have the AI lab, we actually had set up, and we actually had an air condition, but then we tweaked it and had some IR remotes and IR systems in place to ensure that the ACs turn on and on off at a particular time depending on the temperatures of GPUs. So that's a fairly interesting thing that we did there. Yeah, moving on to the next aspect, networking.
Yeah. I think networking is again one critical aspect, because a lot of things that happen like inference, training, or doing LLM apps, so whichever area you pick from the AI, all needs a good networking components. Now, networking accelerators are also again divided into like a one node networking and like a multi-node networking. Within one node, we have again multiple accelerators. Like there are libraries or tools or some advancement where you can skip PCIs and you can directly access the memory. Those things. You have NV links to have communication between GPU to GPU within a node. And when you move beyond one node, again you have InfiniBand, Rocky, and all these fast networking topologies. So basically, you can have a InfiniBand switch in between that connects multiple GPU nodes across the data center, and you can still have like a 400 gigs of network. But all this is in theory. Like when you're using it, or you're deploying your own inference workloads, and let's say you're using parallelism techniques, you need to make sure that your inference engines are basically communicating at those speeds. And that's where you need to measure your entire network throughput and latency. You need to be on top of it, because there's no value if it is only on paper that you're using 4 gigs. You might need to do some tuning in your applications, some performance to get those performance gains. So it could be a GPU to GPU communication bandwidth within a one single node. So if you're not on like latest systems, then probably you have to still measure how much your PCI time is going into communication between the GPU. But if you are on the latest systems, you are using NVLink and all, then are you utilizing those bandwidth effectively? Your 8 GPUs are basically communicating at about 900 gigs or something that NVLink commits. You have to make sure that, or whatever you feel that the best your workloads can achieve, you have to be on top of it. You have InfiniBand, RDMA. Basically, these are used for multiple nodes communication. So when you have multiple nodes, GPU nodes spread across a data center, and you're running like an inference with a parallelism, you have tensor parallelism, let's say any data parallelism. You have to data transfer between these two inference engines. So you have to measure those, like, are they taking too much time? Are we using the proper InfiniBand range to achieve that? All this and when we go to the other slide on the storage systems, we'll see the impact of why network bandwidth is even critical when we talk about the storage systems. So when we see modern storage systems for this AI cloud data centers, again, they are very much network heavy. So you can have like a DGX box or an GX box with like a 20 or 30 TB of disk attached to it. But again, within that disk, you have to basically use tools like GPU direct storage or direct memory access DMA technologies, so that you don't spend cycles where your GPU goes first to CPU or RAM and then gets the data from your disk. So if you utilize DMA and all these toolings properly, you're basically directly connecting to your disk and then getting the data. This happens for your one node. But when you again take the same networking approach and we go to the across entire data center, again we have like modern network interface cards based on like connectX and all, and in between you will again have the same InfiniBand, Rocky, and whatnot. Now again, you have to make sure that when the GPU to GPU networking or a GPU to GPU data access is happening, you are basically not spending too much time on the CPU cycles or RAMs and all those things, and you are using all these RDMA and technologies properly. So bottom line, you have to always measure for any storage systems. You have to measure the IOPS. You have to measure the storage throughput, latency, or capacity utilization. That being any system you use NFS, direct storages, you use parallel file system. These are the key indicators, right? But if you go beyond that, you have direct memory access and RDMA, and these are more mix of networking based things. So you need to be aware of how your GPU direct storage throughput is. Are you really bypassing the PCI and getting that performance gain? Are you doing RDMA throughput? So how much are you using that complete network bandwidth that is happening over there? For parallel file systems, again, they provide the efficiency that multiple processes can access the data at the same time. So you need to be on top of it. What is your file creation and access time? If your network is still, you need to identify, like, is your network is a bottleneck or is the solution that you're using is a bottleneck? So to identify those things, you have to be on top of your latency metrics and all those things. And that's where the mix of networking and storage in a GPU cloud comes in picture. Yeah. Now, we spoke about network, we spoke about infrastructure, but how do you actually do it? So I think in our last webinar also we mentioned that we are using Kubernetes, and many of things that we are seeing, people are using Kubernetes in creating data center, creating the clusters of distributed clusters. Right. So when you're using Kubernetes, the stack that we mostly use based on the open source stack is Prometheus Grafana based stack. For general cluster metrics, cluster performance, and all those things. But if you want to get the metrics of like GPU, whatever we spoke earlier, like about networking, storage, GPU utilization, temperature, and all those things, you can use a DCGM exporter. This is by NVIDIA, and it already exports all of these metrics. It even exports metrics around your vGPUs, your mix, and your GPU allocations, and all those things. So your entire hardware as well as software layer, both are covered by that. There are certain other open source exporters as well, but they're not that mature, so I'm not included here. But yeah, if you want to explore more deeper, there are some custom exporters.
Right. So I think before we get into the observing model part of things, I think it's very crucial for us to understand what all goes behind the application that you use. So now that when you give a prompt to a chat GPT or Claude, you know what are the different layers which are there and how they are working. It was only in the previous webinar that I learned the importance of networking and storage when it comes to building your AI infrastructure. Like many of you, for me, it was all about that. Hey, hook up a very high, VRAM GPU, and then everything works. But then the networking and storage needs to be there to support it, so that the entire system is not bottleneck. So I think Aman gave real good insights into what are the exact things that you need to, measure when it comes to your storage or networking bandwidth or even the GPU as well. So now we shift our focus to a higher layer, moving from the infrastructure, getting into the models layer. And again, Aman will help us understand what are the different ways and the metrics that we can measure if you want to track our AI models in place.
Sure. So before we get into like observability for models, so the one thing to clarify, like common confusion is what is the difference between the AI model backend versus a model server. So there are two components. When we talk about backends, you can even call it like engines as well. But these are the basically the actual boxes where your model is actually going to run. So all the optimization tunings, like you must have heard about like attention mechanism, page attention. You have kernel fusions and all these technologies coming in that do perform the optimizations on the GPU processing. All these things are baked inside the engines. So engines are the ones that are responsible for providing the last mile of that performance gains. So if you have to tune in anything to improve your performance of your inference, then probably engines will be the layer that to start with. You need to be sure that you're using all these things properly. Then you have servers, and servers are basically a wrapper on top of these, or it could be certain other things, other tools as well. Now, servers basically have one part as engine, and the other part is basically the how they make it accessible to the end users. So you might need to have like something to expose out the metrics, or collect those metrics and expose those metrics out to the observability layer, right? So that is one part of the servers. You then have certain front end tooling connection handling, like HTTP, gRPC connections. Who will handle those connections and how it will be delegated to your engines? So those are the things that are covered in the servers part. So if you see the backend capabilities, mostly it is about the memory optimization, model-specific optimization, or batching support. So we'll see more about it, but broadly the difference is you can assume backend as a core server or core engine that actually runs your model, and server is just like your in normal world. If I have to give an analogy, it's like a web server. You put your application code inside this web server, and then it just does all the other things of like scaling, you have request queuing, multi-model serving, any engine supports, all these things it handles. So now, when you go about model backends, what actually model backend for? Like I was saying, they are made to provide a layer of optimization. When you're serving your models, the role of an engine is to provide complete optimization that you can gain the performance gain. You can get quick responses from the models. You're generating at the speed that you're expecting. Because when you're using it like in a chatbot or something, the latency that you're expecting should be less than like it should be a milliseconds of latency that you're expecting. You need the response as fast as possible, like we see on the Chat GPT, Claude, and all these tools. So for that, what they do is engines provide things like batching strategies. You have the traditional way is individual requests come in, they are sent to the server and they are processed. Then you have dynamic batching, which is basically like a time-based or a count-based thing. Like either 5 requests came in or 1 second happened, it will process all the requests that came in by that time. Now, the things that are advancements in this space is like continuous batching. So if a request came in, even after the previous request is already processing, it will still be included in the same batch because LLMs can support that model. It's just specifically to LLMs that they can support this kind of model. It is being used. Now, these advancements, these are only provided by the engines. And when you are using them, what is critical for you to observe is, are you getting this batching metrics or are they really providing you that gain, the latency and throughput gain? Is your end-to-end latency is getting reduced? Is your throughput is good? Are you able to generate more tokens per second? So what is the time for your per token, right? And you can relate it with your GPU utilization to make sure that the token that you're getting and the GPU are utilized in the similar manners. Then within the LLMs, there is a lot of things that have happened with the attentions and all these things, the key value caching, right? So key value pairs are critical because they are being, as an LLM, it's an auto-regressive mode. It generates multiple tokens. Every time it generates a new token, it sends it back and again generate a new token. And it keep on doing it until the end is reached. So within that, we do a KV caching. There are different methods to it. Some do through paste mechanism. Some do the normal KV caching in the memory and all those things. But critical for as an observer or when you're doing it in observability, it's very critical to understand and see that are you utilizing the memory effectively? Because beyond a certain limit, GPU memories are not the bottleneck to the inference performance. It's more of the optimizations that you do, how much your KV cache is being utilized, how much new tokens are every time generated, or requests are always being processed. So you have to make sure that your inference performance is being optimized
And I think Aman
always being
has.
bypassed and sent to the model directly. Yeah,
So,
some
so Aman,
network
there
issue
was a
again, I
blip.
think.
Yes, yes, we can come
Yeah,
back to computation part.
yeah. Sure. Where I was, I mean, if I have,
No, so you were talking about
what
the
was it?
computation process with caching, how the tokens are, generated. That was the part where we lost you.
Yeah. So, like I said, the LLM generated in an auto-regressive manner. So you have the token generated. It goes back to the again attached to the original sentence, and then you again generate the next token. So you can see that the previous context remains same. So you can probably store that as a cache. Now there are techniques to it like paged attention or standard attention-based mechanism using GPU memories and all. So what to critical is to track here is you need to be sure that you're using the KV cache properly, right? You are not doing a lot of skips to that, and that is being used effectively. Whichever mechanism you're using, if you're using VLLM, it might be a paged attention, so you have to measure that are the swapping and all those things are happening properly. So yeah, I think these are the critical metrics that comes to when it is KV caching or like model load times, and you have like different phases within an LM like pre-fill, decode. It starts with the pre-fill and then it continuously go in the decode phase. So you have to measure latency at each stages, and that will give you an indication that where actually you need to do the mode tuning.
Interesting. So I think before we move into the model serving area, I think until now, what I have realized is that the depth of details that Aman, you have shared, and I think Chandra, who is one of our viewers, who also agrees that we have provided good depth of details, whether it comes to the GPU slide or even the previous model slide. I'm sure that at least for me, the way I will look at how the Chat GPT or Claude actually works in backend has completely changed. Now I can visualize what happens when I send a request, what happens in the background, and how it is, let's say it is tokenized and how it goes to the inference server and so on and so forth. So thanks, Chandra, for those good feedback. We are open for questions always. So if you have any questions, please drop into the comments, and Aman would be more than happy to answer. And also, we have written a couple of blogs around AI, especially around GPUs, time slicing, and as well as network. So do check out our blogs on infracloud.io/blogs, where you can get on more details as well. So with that, let us move to the final layer, which was about observing the model serving layer, which essentially is where the end users, interact with. So let us see what are the various metrics that we need to track and the focus areas for us.
So this is the final layer. I think when it comes to inference, at least, basically, if you have to relate it with your whatever current microservices or current kind of deployment that we do, non-GPU kind of thing, it is basically a server that we are deploying. Engine is part of it. Now, what matters here, like other normal microservices or applications, are they being scaled? Are they how the requests are being handled? What are the interfaces that are open? Is it HTTP, gRPC, and whatnot? Because it's a role of server to take that request and pass it on to the engine, and then engine does the all these optimization that we spoke about, like batching and all those things. Now when it comes to Kubernetes, or we all know that it is good for scaling the workload, scaling up, scaling down. Both things can happen using the HPS and all, right? So server again brings up that role. So when we tie the observability of server with HPS and all, we can again use the same principles that we use for normal pods and scale our inference servers based on that. When we talk about the allocations, like at the first slide, spoke about GPU sharing strategies like MIG. So you can, in the diagram, if you can see, there's a MIG, right? And we, let's say, created 4 GPUs out of it. Then you can allocate 4 inference server onto it. It depends. I'm not saying like it will fit in all the cases, but if you're using a small model, it can just run a 4 replicas within one GPU, and still they are isolated. They are like completely different pod replicas that are running. So that's the key roles of as a server. And again, like other web server, we have to track here like a latency for end-to-end requests, because this is the layer where actual interaction happens. It could be that you are doing some processing in between, and then you are passing it to LLM, and then you're getting the responses back, and again doing some processing and then sending it out. So your end-to-end request changes for that, and it could be tied with your this web servers. You need to be on top of like how much your request per second is and how much your tokens per second. Auto scaling metrics for servers like we spoke, and load distribution across the servers.
Interesting. So
Yeah,
the
I think
model
this is
serving,
all. Yeah.
yeah. So model serving, like you said, is the area where we all interact with. As users, this is where we hit, and like a typical web server, if I can say, we track the metrics which you mentioned, from latency to throughput, so on and so forth. So overall, until now, we looked at the various layers that we have to observe when it comes to AI platforms. So we started with infrastructure. We spoke about storage. We spoke about networking, GPU, and then we moved one layer above, and then we looked at the backends where we, how to track them and what are the various metrics, and then finally we reach the topmost layer where we interact with. So the next part would be the demo. Enough of theory. I think we have discussed a lot of things today, and I'm sure we will have something interesting when we go into the demo. So before I go into the demo, Aman, we have a question from one of our viewers on LinkedIn, Ishank, and I will just flash that question on the screen. Yeah, right there. So Ishank Bansal asked us, can you touch upon some cost measures while we integrate observability with AI? Based on the session, I am assuming it will incur huge cost as well.
So I think it again relates to the first slide that we had, the triad of observability. So if you're doing something like let's say training workloads, so if you're doing like developing LLM apps, yes, a lot of metrics will be generated in those cases, because basically when you're developing LLM apps, it's just like you're developing your current apps. You might have traces, you might have small metrics, you are running in debug mode, you will be collecting a lot of different data points. So at that time it might be higher, but when it comes to inference, it's basically like let's say your application is now packaged and you're putting it in production. So the amount of logs or metrics that will come out will not be as huge as it is for the other things. And Indian for the infrastructure layer, I think barring the GPU utilization metrics or networking component metrics, other things we anyways used to capture it, right? In the Kubernetes cluster, we capture the node details. Even in a normal EC2, any server-based instance, we are habitual to capture those metrics, like how the CPU performance is, memory performance. So that will not bring a lot of big metrics down. And again, it depends on the overall size of your setup. So if you're living in a huge data center, then yes. But if you're a small lab, then no.
Great. I hope Ishank, Aman has answered your question. And if you have anything following, do let us know in the comments, and Aman would be more than happy to answer those. So yeah, if you missed that previous webinar, what you see on this slide is the photo of our sandbox AI lab that is present in our office in Pune. And this is where the team is doing some exciting stuff. And one of them would be what Aman will be showing us today, focusing on the observability aspects of AI platforms.
Sure. So before we get into the actual dashboards and scheme, just a background of our AI lab, like Atul mentioned just now, that in the last webinar we have already demoed this. But just in high level view, we are running a 3-node GPU-based worker nodes, 3 worker nodes, and they are using RTX 4090 GPUs. We'll have deployed 1 or 2 inference servers on these. It's entirely Kubernetes-based setup. Then what we on the software stack, if we on the software stack, so OS provisioning, you're doing Pixie boot and all to bring up the entire systems and all. Orchestration layer, like I just mentioned, we are using Kubernetes. For GPU integrations, we are using GPU operators and networking operators. On the load balancer side, we are Metal LB we're using. And for monitoring, like I said, we are using very light layers of like Prometheus, Grafana, node exporters, and Nvidia DCGM exporter. Since it is a miniature lab, we are not other GPUs and other kind of set configurations. But yeah, this will give you a good insight onto whatever we just discussed in the session. Just an overview of the kind of app that we have deployed on the system right now. So it is more of like a RAG app as an example. What it is at the bottom, we have the Kubernetes cluster. Prometheus, Grafana, Loki, and all these things for monitoring part, and GPU operators, load balancers, file system for access. On top of that, we have deployed an AI stack, which is basically an inference server. We are using the TGI patient inference server. We have an embedding server that basically chunks out the data, or if you can upload something, custom files or RAG, then it can do that as well. And we access it through, currently it's not through an LLM gateway, but we are directly accessing through Metal LBs right now. But yeah, that's the goal that we are planning.
Great. So I think Aman did give us a good overview on the AI lab that we have, the various applications that we have, the various layers, and the various components. Now we'll deep dive into the demo now, which Aman is going to show up. So Aman, you can bring up your screen so that we can show it to folks on what exactly we have done here and how they can make their system observable. So in 3, 2, 1, here we have Aman's screen.
All right. So what I'm going to show is just the context, like the entire app system that I mentioned. I've been using it before the webinar and generated some queries, questions, and all those things. Basically, normal inference, just like ChatGPT. I'll go layer by layer. Let's start from infrastructure, and then we'll look at the backends and the servers metrics. So if I start with the GPUs, so like I said, very critical to measure the temperature, power usage, and power total consumptions and all. If you see currently, wherever the model is deployed, there are certain high spikes of temperature usage. The power usage is high on those nodes. These are the actual nodes where our actual inference server. So we have deployed a Llama 3.18 billion model and using a TGI server. TGI is basically a combination of a server as well as a backend. Right? It's using both within the same module. Now we can even see the GPU utilizations. If I just increase the time window when I was doing the queries, you can see a lot of fluctuations. When I made the queries, the GPU's utilization spiked during those times because I was making bigger batch sizes of queries. You can monitor the streaming multiprocessors. Basically, these are the final core units of GPUs that actually do the processing stages, and so that's where actual processing happens. You have the frame buffer memory, which is basically where when you do model load, you have parameters, you have key values, and all those things that are basically being loaded in the GPU memory. So we call it like a VRAM, and that is what frame buffer actually deposits. So you see that on the InfraCloud 0 and GPU 0, which is where my model is actually deployed. There we are running around 23.2 GB because we are running Llama 3.8 billion, and it is a quantized version. And with all the maths done, it should take only less than 24 GB. So it's very near to it. So you can see it's the same comes out here. On the other node, we are running an embedding server. So that doesn't need too much of memories and all those things. So it's just using a 2.61 GB. So this is majorly around the GPU part. But if I switch back to a normal typical Kubernetes cluster utilization, we can see we can again monitor, and this is not related to specifically to GPUs or anything, right? This is around normal cluster metrics. So you have CPU utilizations, what are the commitments, how the memory utilization is happening. You can see namespace-based utilizations, how the memory is being utilized across those namespaces and all. And if I have to go into any of these into deeper, I can just switch to that and get more details of it. Like I'm using AI stack, so whatever the CPU usage is, I can capture those things. And this is pretty generic. I mean, like I said, it is not like it is related to certain GPU or anything. It is more of like a Kubernetes dashboard that come with node exporters and Kubernetes set of Grafana dashboards. After that, I'll switch to our inference. So like I said, we are using TGI right now. And if I switch to the 1 hour window, because I was making all these requests before the webinar. So like I said, critical parts as the top ones that we are seeing right now, these you can directly relate to your model backends. So model backend, like I said, is to mainly to provide you the performance gain. So you can see the time to first token. You always need to be on top of it. How much time it is taking? Is it like going into seconds? Then probably you really need to do either some hardware checks, or you have to check the model backend. Is it being tuned or not? Is the model right fit for you or not? All these 13 questions comes. Decode per token latency, basically, like we discussed earlier, like pre-fill, decode, these are the stages of an LLM, right? So you need decode is where the major work happens, and that's where you have to see that how much latency is happening, because that is directly related to your end user latencies as well. Throughput, not like normal web applications, it's not like the number of requests that are being served, it is more of like a number of tokens generated per second, and that is where you see the speed when you talk to any chat GPT or anything, like if you're how frequently you are getting the responses back. So how frequently it generates the token, it's the same way, at the same speed it can basically, in the relevance to it, it can deliver it or it can stream it to the end user. General metrics around how many tokens per prompt were submitted, and then how many tokens were generated per request. Now, these are, when it comes to TGI, these are the metrics that we can observe right now. Since we are at a miniature lab, we are not at the scaled out lab. If it is like 100 servers and running a parallelism based inference, we might be capturing more metrics. We might have to go into the network part of it, storage part, and all those things. That is not relevant to our lab right now, because we are just running it on the one single node at this moment. Now, if you see on the server side, so you can see the requests that are coming in and how much time they are taking, what is the per token latencies and all those things. So these are two deep metrics, like if you have to look at the batching metrics, how many tokens per batch happened, what is the batch size that you're doing. You can increase it in the configurations of your engines, and that will be reflected here. So if, like we discussed earlier, like if you increase the batch sizes or if you change the batching mode, then it probably changes the way your responses are generated or the speed at which it is generated. I mean, there are more to it, but like I said, we are running a very miniature lab, and within that context, on the one single TG and a one single node, I think these are the metrics that we can capture at this moment. But yeah, there are many other things that we can capture on the networking side, storage side. If you're using inference parallelism, then there are completely different metrics that you have to track. So yeah, probably in further webinars, we might add those as well.
Interesting. I think Aman has repeatedly mentioned that there are more metrics, but then if you look at this dashboard, there are already 100 numbers which I can see on the dashboard. And I think all the ones that we saw, Aman did cover almost each of them when we were discussing earlier in the webinar today. On all the aspects, right from infrastructure layer, talking about the power consumption of GPUs, like he showed, and then he showed us how the Kubernetes normal metrics are, coming from, let's say, a node exporter, which tells me how my pods are functioning, how my cluster is functioning, and then eventually coming to the inference server, where we have these details when it talks about the batching modes, the time to first token, etc. So there is a lot of math involved. And this math is not only involved to build your model, but even when it comes to monitoring and ensuring the key performance, these are critical as well. So once again, I think we are almost at the end of the webinar with the demo. So if you have any questions, feel free to drop them in the comments, and Aman would be more than happy to take them. And coming back to our, the AI lab that we spoke about. So whatever you saw in terms of the setup, the applications that we are using, the Kubernetes cluster and everything on top of it. If you are planning to build something like that with similar infrastructure and the components, then you are lucky, because we have open sourced all the charts that are used to bring this infrastructure up. So do scan this QR code. It will take you to our GitHub repository, where you will find all the charts that is required to bring this infrastructure up. So you have your TGIs, you have your TEIs, you have your vector DBs, everything that is required to get your system up and running. So, do go ahead and check this out if you are planning to make something of this sort. And, you can very well reach out to me, Aman, or any one of us at InfraCloud if you are facing any issues. And, we would be more than happy to help you out here and there. So we can now move to see if there are any questions. So there was one question by Savinay, which was asking about, will this be recorded and shared? Yes, Savinay, this webinar is recorded, so you would be able to see it on our YouTube channel. So you can check there. And while I'm going through this, I have more of feedback coming in than questions, which is again very exciting and inviting. So thank you so much, Gaurav, for your kind words that you liked whatever we showed, and also thanks to Chandra, for acknowledging the efforts that Aman actually put in to get the demo and the everything else in place. So I guess we are good in terms of question, and we are at the top of the hour as well. So before we close in, I will ask Aman to give in a few closing remarks on when it comes to observability in AI. Obviously, we looked at the various aspects that are involved, how complex it is. But then if someone is setting up observability for their infrastructure, what are some things that they should keep in mind while they are building something of that sort? So we will leave our audience with those pearls of wisdom that you will share with them.
Sure. Yeah. Yeah, I think this is a very trending and a very fast-moving space, right? We are seeing every day something new coming up, right? So, like we said, like in the earlier slides, you need to identify first yourself where you are in the of this AI world. Are you training? Are you building an apps, or are you just doing an inference? And if you streamline that part, you will just remove a lot of metrics and a lot of things, overheads that you have to track. So once you have a clarity on that and what systems you're using, are you on a cloud? Are you building on your own private data centers? These things mix up, and once you have that clarity, you will be very well defined. Like we just did with one exporter, which is Nvidia DCGM exporter. So you don't have to like over engineer it. If you're using one stack, using only Nvidia and certain toolings around it, you might not need much more exporters. You can just plug in your existing Prometheus Grafana system, point the exporters to it, and just use it. But if you are using complex workloads, some third-party apps, and all those things, you might have to invest more time on integrating their systems and all those things. So just identify the space you are in, the stack that you have, and then just don't over engineer. Is because this is very fast moving.
Yes, I think the fundamental answer, keep it simple, silly. I think that applies to
Right.
everything that you do. Figure out where you are and what your needs are, and accordingly, apply the tools and tech. I think before we close, my dear friend Ram Iyengar has a question for Aman. So we'll just flash that on the screen. So Aman, Ram asks, what are the hardest parts of setting up AI infra according to you? And for a company wanting to make a publicly available API or SaaS.
Right. Yeah. So I think if you're making the second part of the question, which is if you're making a SaaS or an API or based solutions, it's the last piece that we covered was your performance metrics. That is really critical because you're basically opening up yourselves to a lot of public and end users. And this even relates to your internal teams as well. If they are using even for the internal tools as well, any inference system, this is the piece where you cannot like change the model overnight, right? It's a foundational models are built and they're getting bigger and bigger. You just take them, quantize, and you probably use them. So you have to work a lot on the optimization part, and you need to focus on the right choice of the engines, right choice of the servers. That is the piece that will give you that performance gain. And when it comes to your AI infra, again, it's a choice. Are you setting up your own lab? Then probably you have to go very deep, understand all the computes that can be used. What is the networking speed that you require? If you're doing only inference, probably less networking. If you're doing training, then you need to look at the broader pictures of all the high level, all the InfiniBand, RDMA, and everything. And if you're on the cloud, then probably these things are not too much of worry for you. You can just subscribe to those services, take those, set it up, and use it. But your observability will help you to track, are you using those cloud services well? So that's where this part will again plug in.
Thanks, Aman, for that answer. So I hope, Ram, you have got your answer around, what are the things or what are the critical components that are required for setting up AI infra, especially when you are an API or SaaS company. So before we close in, thank you so much, Aman, for your time and also for sharing insights, deep insights, if I may say, with all of us. I'm sure there's a lot of takeaways for everyone from this webinar, even for me as well. And for everyone who has joined in, thank you so much for joining in. And we will be coming up with future episodes of this webinar. So we started with talking about the AI lab that we set up, and then today we focused on observability. And similarly, you might have realized until now that it's a very complex field, and as and when you start working with it, you realize the various layers and various components involved in it. So we would be coming up with more future more webinars in the future. So do scan this QR code so that you are notified whenever we are coming up with a new session. So with that, once again, thank you so much everyone for joining in. It was a great time having all of you here. Thanks to Aman as well. Thanks to Vishal who had to drop off for a meeting. And I'll be looking forward to seeing all of you again on our next webinar. So do keep your eye on our social channels. Follow us on Twitter, follow us on LinkedIn so that you are updated with the latest webinar and content as well. So until then, goodbye, good evening, have a great day wherever you're joining in from, and we will see you again in our next webinar. Thank you so much.